So hello and welcome to Online Study for You, a complete placement solution. So since yesterday Mitsogo Technology have launched their round 1 results, and now those who have qualified that they have their technical round ahead. So for that we have bring this video for you in which we are going to solve the previous year Mitsogo Technologies coding question which were asked in their technical round. Okay. So actually, two questions were asked in that technical round of coding portion, and we are going to solve two here, which were asked in previous year examination. So let's start with the first problem. So you can see on the screen, the first problem is being written. So the problem statement says, let me, okay, now you can see this. So the problem statement is warehouse of automobile factory. And the statement is written as follows. You are working in the warehouse of an automobile company and you are required to sell automobile part in the wholesale market. Okay. You are given two arrays. So you have been given, and the array will be first array is unique ID array, which is of size n, denoting the unique ID of each automobile part. Okay. Now the second array is profit array, and that too of size n, and the profit array can be earned by selling each part. Okay, so whatever the amount is being written in profit uh, array of that index is the amount referring to the unique ID index the of that part. By selling you can get that. Okay, now what we have to do, your task is to return the maximum profit that can be earned by selling the automobile part in the market. Okay, so we have to sell the automobile parts in the market, and by that we earn some money. So we have to give him the example that what is the maximum possible profit that we can earn by selling it. So now in the note portion it is written, if two or more consecutive part in unique ID have the same ID, then only amongst them, one amongst them with maximum profit can be sold. So now it is the interesting part of this problem. So here the constraint has been given that if there is a consecutive means that comes directly one after another. Now, if two or more consecutive part in unique ID have same ID, then only the one, okay, let me change the pen color. Only the one amongst them with the maximum profit can be sold. So this thing we have to keep in mind while solving this problem. Now, check other parts also. The input specification has been given here. The size of the array is input, obviously. And then the unique ID is given. Again, the same size of array is as profit, because profit and unique ID array is of both of size n. So both are is of size n. Now integer 4 is integer n denoting the length of array profit. So there will be this 4 input that we have to take in our code. So first is the size of array, let's say n. Then the unique ID, let's say we can tell here unique of size n. And then let's say the array of integer denoting profit, which is we can take m. We know n equal to m, but for the sake of the problem, we have to take another variable. So m, and then the integer n denoting, okay, here it is written both are the same, but for the problem we are taking it. Then the profit of size m. So are the 4 input that we have to consider for this problem. Okay, and unique of n, m, profit of m. Okay, now so output specification is given, that what actually we have to put or give output to the user or to compiler. An integer denoting the maximum sum profit can be earned. So we have to return the int of answer which contains the maximum profit. Okay, now here some example test cases been given, and accordingly the answer is also been given. You can see first array, then size of the array, then input of array 3, then size. Accordingly it is been given. And now what you have to do, you have to solve the problem for here itself. Here explanation of this also given, but let me discuss this problem to you in detail, then we are moved to the coding part. Okay, first we have to discuss the approach. Now you can see the problem. So what we have been given, actually let me write the content we have been given a size n, then the same of the size is unique of n, which contain the unique ID, and then the same of the size is profit, which contains the profit. Okay, profit by selling. So now we have, when there is given that we have to give them the maximum possible sum that we can get by selling our items, but there the constraint is whenever there is some consecutive uh, same unique ID occurs, then we have to choose only the largest profit value only. Okay, so that is the case that we have to keep in mind. So now let's take the first example for that. The first example is unique ID is given as 4. Let me show it again. 4. Okay, can I do it here? No. 4, 6, 3, 3, and 4. And accordingly, the profit has been given -1, 10, 10, 15, and -5. Now you can see here. So the first we have to always check for this constraint. Okay, we have to always check for this constraint. This constraint is very important. Now you can see here the first one is given, the unique ID is 4 and the value that corresponds to it is -1. So the whenever any, by selling something you get the -1 value, that means you have not get any profit, but you are in the loss. That means you are selling something to others, and in the comparison, you are only giving him the money. That only means by minus sign. Let's say by selling something, you get 10 rupees loss. Then that means that business is not profitable. You have either you keep it to yourself only, no? Why do you have to sell to anyone if you are getting lost by selling it to someone? So whenever we are getting any profit and negative, so we can't take it. That is the common sense that we usually anyone have. So this thing we have to consider the first edge cases. Whenever some profit value is negative, we surely don't sell that item and we don't consider that in our answer. Now move to the next portion. Now the next unique ID is 6 and the value correspond to it is 10. Value correspond to it is 10. So simply there is a unique ID and we are selling the parts with that unique ID. We are getting some value which is 10. So surely we will do that. We simply sell this one, and by selling this we are getting our value as 10. So now after visiting the two unique IDs, we get to know that we don't have to sell one which have negative values, and we are selling the unique ID by which we are getting some profit. So we are selling the unique ID with 10 profit and we are getting the 10 profit and we are adding it in our answer. That's the simple part. Now move to the interesting part of this problem. Now here you can see again the next unique ID is 3, and by selling that unique ID we are getting a profit of 10. So usually what we will do, we will simply sell that and get the profit. But here the catch is, my friend. You can see in this problem, the statement is written whenever some consecutive unique ID, same unique ID occurs. And here you can see consecutive means you can two unique ID, two consecutive unique ID which occurs one after another with same unique ID. Then we have to choose only one which have the largest profit amongst them. So we only have to choose one between these two unique ID with same unique ID as 3. So what we will choose? It is a simple case. We will choose 15 instead of 10 because we are, by selling this part, we are getting more profit. So we are not selling this, we are selling this part. So we are selling simply this part and we are getting some profit here also. Now, okay, move further. So 10 plus 15 will be what? Till now we are getting our profit as 25. Now the next part is 4. Since 4 have no consecutive unique ID, so we can sell that. But here again the catch is, by selling that, we are getting a loss of -5. So why we consider a loss? We do not have to sell that. We either keep it. So we don't sell it. So by iterating through all the automobile part in the unique ID array and corresponding to the profit, we get to know that we can sell the two part with unique ID this 6 and this 3. And by selling those two parts, we are getting our profit as 25. And you can see the answer is also 25. So we are getting a correct output. So I hope you understood that how actually this code is being working and what are the constraints of this code. Now let's see the another problem to understand it in better way. So come here, come down to a. So now you can see, okay, there is a slightly typing mistake because we have to type it down. Here it is 1, okay? So basically the unique ID is 2121, sorry, and the corresponding profit value is 10, 20, and 30. Understood? Now, again, we have to do the same portion. So answer will be initially assigned to 0 only. And now we are going to see the first unique ID. So our first unique ID is 1. And the value correspond to this one is 10. We have to sell it because the next consecutive item, because we have to check the no, but that next value is consecutive to it or not. If it is consecutive, then we have to follow that rule that uh, only one of the all consecutive unique IDs which have maximum value is to be sold only. Okay. So now what we are going to do here, we are checking that the next value of it, if it is a unique ID or not. So here we can see it is not a unique ID. So we can simply sell it. Sell it. Okay. Sell it because this one is 2 and they are not the same. So we simply sell this one because we are getting some profit by selling it. So we are getting the profit is 10. Understood? Clear? Easy problem? Okay, now move to the next. Now here you can see again 2. Again the 2, and someone have doubt that here the two ones have occurred, so this one have value 10 and this one will have value 30, so why we choose to sell this, we have to sell this only. No, if you have this doubt, then please let me remind you that we only consider that case where we have to choose any one of amongst some values when they occurs with consecutive time. But here you can see this 1 to 1 is not consecutive because in between them there is a 2 occurs, so this is not consecutive. If they are consecutive, then this could be like this or this could be like this, then we can say this one or this one is consecutive. That means they are after one another. Okay, if you haven't that doubt, then let me clear that for you. Now move to the next iteration. Now the next one I have unique ID 2 and value associated with that is 20. So we simply sell that also because the next value of that is 1. So there is no consecutivity term here. So we simply add that. And again, this value 1 occurs. And since there is no other value uh, after that, so it has no consecutive values. So we simply add that to our answer. So the value is coming as 20 plus 10 plus 30 will be 60, and we are getting our answer. So this is the way by which we are going to solve that problem. So I hope you understood that how actually the problem is being solved. Now, how actually we are going to solve it in our coding language. So we are going to solve this problem in C++ and Java both. So both the audience who have solving it in C++ or in Java will get benefited by that. So don't worry about that. And if you are coding in any other language, then also this video is for you because we are going to first discuss the logic, that how actually the code is being written. Then we are going to code it in some language. So if you understood the logic, then you can easily translate it into any other language that you are coding at. Okay. Now, so we are from where we are going to discuss our logic. So our logic is simply three constraints. We are only have to look for three constraints while choosing some value to take sell it or not sell it. Okay. Three constraints for sell or not sell. I hope you understood. So first constraint is what? Value should be positive to sell it. Okay, to sell. If the value is no negative, sorry, is profit value, my bad, let me write it correctly. Profit value should be positive because when if positive value, if the value is negative, then what it is mean to solve that? Why do we solve? Why do we sell that? We don't have to sell. Now, this is the first constraint that we have to look for. Now, the second constraint is what? The consecutiveness. The consecutiveness. We have to check for the consecutivity. Matlab, means if there is a consecutive number with same unique ID or not. Consecutive with same unique ID. If that occurs, then the third constraint is active. We have to select the maximum amongst them. Maximum amongst them. So this is the three constraint that we have to look for. First, if it is a negative or positive, otherwise consecutivity, and if consecutivity occurs, then we have to check for the maximum value. So how do we solve that? So let's me take an example so you can better understand it. Let me take the unique ID 1, 2, 2, 2, and 3, and 4. Let's say this will be case. So it is of value 6, okay? Array of size 6, and this is a unique ID, or you can say UID, or this is a profit. And the profit is namely as, let's say we can take 2, 3, 5, 4, and then this is -1, and this profit is, let's say, 6. Let's take any value, okay? So how do we actually solve this problem? So see, we are going to iterate over this unique array. Iterate over this unique array. So let me start with index I equal to 0. So this is I equal to 0. So we are at this 1. Now, when we are at this one, so let me iterate it for int I equal to 0, I less than 6, I plus plus. 6 is the basically n. 6 is equal to n. So let me write n here. Okay. N is basically 6. So I equal to 0, I less than n, and I plus plus. So we are iterating our every element of the array. Now, so whenever we are iterating, first constraint we have to consider is that we we should not have to add the negative values. So for that, what we are going to do, we are taking a variable, let's say max value. Okay, max value, let's say, which is initialized to 0, which is initialized to 0. Okay, and why I am doing that, you are get to understand just right after, wait for a few minutes. Okay, is initialized, this is being initialized, a variable with name maxwell is being initialized with the value 0. Now let's move forward. Okay. Okay. So now what we have to do, we have to check for the consecutivity. What is consecutivity? We have to check the next index, just right next index of this I equal to 0, because we are at I equal to 0. So we have to check for I equal to 1 that if this index of the unique ID is of same of this one or not. If it is same, then there is a case of unique consecutivity with same unique ID. Then we have to consider for the maximum value amongst them. Otherwise, if it is not the case, then we simply decide by negative or positive values. Okay. So what we are going to do here, the catch is why we are initializing this value to 0. That is the case you can get to understand here. Okay. So let's move here. So max value, which will be initialized to maximum of sorry, let's say this is called as profit. So profit of I or max of well. I hope you understood this. Okay. So it is being initialized. So our max value is initially 0. That means if this value will be -2, then also this -2 haven't been taken because our max minimum value is being 0. So whatever the case, the negative value haven't been taken by this code because we are taking the maximum of both of them. If this is positive, then we have to take it down. But if it is negative, then we haven't need to take that. Okay. And for your clarity, let me take -2 here instead of 2. So in spite of the value -2, what we are doing, so in Maxwell, what will be stored? The maximum of what is profit of I -2, and what is Maxwell 0. So what is the maximum between -2 and 0? It is 0. So that is the need of taking initializing it to 0 and writing this code. So whenever the any negative value occurs, we haven't need to take that in our value or in our answer. Okay. Now, no. Let me change the color of my pen. Okay, let me small it down. Okay, now fine. So this is the case. Now we are going to check for the consecutivity. Okay. What is the consecutivity? This is for positive or negative. This is for positive or negative. This is the first constraint that we are handling by this method. Now, second constraint is for checking for the consecutivity. The second constraint is for checking for the consecutivity. I've written the three constraint here that we are going to mention in that code. So inside this, we are running again a loop. Int j, another value is I plus 1. So j will be initialized to this. Okay, j will be initialized to this one also. And j less than n, because j shouldn't be go beyond the index of array. And now we are going to check. We are going to check that if the array, sorry, not array, if uid or unique id what is, of I is equal to uid of j or not. If both of them are equal, that means there is a case of case of what? Consecutivity. So we are going to take the maximum amongst the value. So previous value is being stored here, whatever the previous value is. Now we are going to compare it with the current maximum value of uid of j. So max val is equal to max val or comma, what you can say, profit of, let me, profit of j. I hope you understood this. Okay. So this is the one case. This is the one case that we are going to look for. But let's say if this is not the case, if there is no consecutive value occurs or the next value is not equal to the previous value, that means the consecutivity constraint is being and, then what we are going to do? Nothing but simply we have to assign just one thing, that our I is now assigned to j minus 1. Why this is I am assigning, you will get to know in some time. But now the other thing is we are breaking down here that no, we don't have to check for other thing. We have done with the checking of consecutivity. So our third constraint is being checked here. And if the third constraint is valid, then this will be our fourth constraint. Sorry, second constraint is valid, then this is for checking the third constraint, that choosing the maximum amongst the same values. And after doing that, we are coming out of the second loop. And now we are in this main loop, the first loop. Now what we are going to do, we in answer variable, we are adding whatever our max val is, and we are reassigning to our max val to 0, because now we are again checking for the new values. Okay. Now again, this same thing will happen. So let me dry run for this for you. Okay. So let's dry run it quickly. So starting from here, you can see, starting from j equal to I plus 1, this will be checked from I initialized to 2 minus 2. So max value is 0. Now there is no case of consecutivity and I is reassigned to j minus 1. So it is j. So I is again reassigned to him. Okay. So I is again coming to this. Okay. Now answer will be nothing but plus equal to 0 will be added, because minus 2 and 0 maximum will be 0. Again, now look here very consciously. Now when I come to here, again, my max val will be what? Maximum of max val and profit of I. So currently my I is this. Okay, this I is ended. And now the max value is 3. Max value is 3. But when I'm going to check for the consecutivity case, then it is a consecutive number with same unique IDs, because this when I checking for j is this, I is this, so j is this, j plus 1. Okay. Now both are equal. So what I'm going to do, I have to compare Maxwell. Currently Maxwell is 3 with the current value of this j. Okay. This is being checked. And since 5 is greater than our Maxwell value, so Maxwell will be reassigned to 5. Again, since it is the case, so we are again checking. So we are not going to else part. We again go for the j equal to I plus j, because j plus plus occurs and j will be moved to here. And again, when I am saying again this and this are equal, that means they are in consecutive order still. So we are going to check for the next value also. So next value is 4 and our max value is 5. So since our max value is already greater than 4, so no updation will be occurred and it will be same at each is. Now again, I am going to check for j plus plus occurs and j will be moved to this. Now, what happens here? When j goes to this index, and the unique ID of this index is 3, and our unique ID of I is 2. So this condition haven't matched. Now we are going to else part, and here you can see our I is reassigned to what? I is reassigned to this. J minus 1, our current J is this, so I is reassigned to this. And by that means we have skipped the checking of this part in the main portion, because we have checked for that consecutive part in our second constraint portion. So by that meaning, we are skipping that portion. And again, we are breaking out, and our maximum value is 5. So 5 will be added. And again, our maximum value will be reassigned to 0. I hope you understood. Now again, go to the this I, now I plus plus occurs. So our new I will move to this 3. Now, whatever the unique ID max profit of this is minus my 1. So it is same 0, because 0 is greater than minus 1. So this case holds. Okay. Now, since there is no consecutivity, so 0 will be added, and again it will be reassigned to 0, which it is. And again, this for this index, there is no consecutive index ahead. So whatever the maximum value between 6 and 0, which is obviously 6, will be added to our answer, and our correct answer will be 11. So I hope you understood that how actually this problem is being solved. So there are actually 3 constraints that we have to look for, and we have point out all the constraints by the example test case, and we write code according to that. So I hope you understood the logic that how actually the code is being written. Now let me write this code for you in Java and C++. Okay. So first, I'm going to write this code for you in C++. Okay. So here what I'm going to do, I have to take an array of integer n, which is the size of profit and unique IDs. And let me take an array of unique ID. Let's say I name it as UID. Okay. And it is of size n. And let me take it as input for int I equal to 0, I less than n, I plus plus. And value is been taken as input UID of I. Okay, cool. Now, the profit in array also will be taken as input, so profit of n, and it is also taken as input in the same way. Okay, so after taking everything as input, now we have to write the logic for that. So for writing logic, first we have to define an answer variable where we will store our answer, and and max val variable, which is used for finding the max val for the current range. And it is reassigned to 0. And now we have to iterate over the array. So that we are doing here. And now we are writing the first constraint, which is max val is equal to maximum of max val or profit of current index I. And now the second constraint is checking for consecutivity. So for int j equal to I plus 1, j less than n, j plus plus, and now we have to check if it is consecutive or not. So what you can say, uh, UID, sorry, I've written UID of I is equal to UID of j. If it is the case, then we have to check for the maximum value amongst all. Okay, maximum val equal to max of max val. Okay, right, and the profit of that jth index. Okay, and and if it is not the case, then we go to the else portion, and in the else part, we are going to do what? We are just reassigning I to j minus 1, and we are going to break out from here. Okay, sorry, break out from here. And after coming out of this for loop, what we are going to do, we are assigning that max value to our answer. And after that, we are reassigning max value to the initialization value of 0. And after iterating through whole the element of the array, We are simply doing nothing but returning our answer. So I hope you understood this code. Now let me run this code for you. Okay. Okay, there is some mistake. Error J is not declared in the scope. Let me show where it is coming for and okay. Here's some mistake. Let me okay. Okay. So let me run it again. Control that. Okay. So the mistake I have found is that I have forgot to take it input. Okay. So and haven't been inputted yet. The silly mistake I have done. So let me run this. Now you can see the code is running very much correctly. So now this is the C++ code and I have written the Java code as well. Let me show you the Java code. So this is the Java code for you. The same code is being written here also. Okay, exactly the same code. And now let me run the code for you. I have taken the input here also. And I hope 25 is coming as output and you can see the output is coming as 25. So this is the first problem that we have discussed right now. And now there is one more problem that we are going to discuss. So let's move to that problem quickly and solve that problem. So this is the second problem. So I hope you will able to see the problem. Let me zoom it for you again. So this is a second problem that is been asked in that coding round, and it is a very good problem to have. So let discuss it. Okay. So the tree is so question is named as maximum tree height, and the statement is written as follows: Harry has n glass of water, and there is an array named as ARR of n positive integers, which you can say represent the amount of water in liters in the glass. Okay, so spelling might be sometime incorrect because we haven't exact question. We just write down the question from the Google images, and we are unable to show the images to you here because of some copyright issue might arise. Okay, now by watering X glass of water a tree of height H, the height of tree will increase by X unit only if the water is more than the height of the tree. Otherwise, it will soak the water and height will not increase. So this is the case that we have to look for. Now, our task is to help Harry to water the tree with initial height 0 using n glasses of water in any order to maximize the height of tree and return the possible height of the tree. So what we have to do, in any order we can plant a tree or water the tree, but during watering we have to consider this case, and now we will have to say that what is the maximum height that we can achieve. Okay, now the input specification is begin that the size of the array which contains the waters in liter that we have to pour to the tree, and the integer array which represent the values of each value of water that we have to pour the tree. Now, the initial height of the tree is 0, which is mentioned in the problem itself. We have to return what is the maximum height of the tree. So this is the problem statement that is looking here. Now let's understand by a problem here. So here input is 3 and the different water combination is given 2, 1 and 2. So we have 3 buckets of water. Let us stack by an example, and the water contains are 2 liter. One is of 2 liter, again one is of 1 liter, and again the third one is of 2 liter. Now we have to pour a tree to get the maximum height, but there is a condition that whatever water we are pouring, the amount of water should be greater than the height of tree. Then only the height will be increased by the whatever the amount of water we are pouring it to. Otherwise, there will be no effect to the tree. The tree will soak it down. Ultimately, it is nullified. Okay. So this is the case that we have to remember here. So for that, what we are going to do, we have simply, it is the brainly logic thing, that we first pour the tree with the minimum possible quantity of water and growing further, so that there can't be a case arises of this, or we try to minimize this case, that whatever water we are pouring to the tree, it shouldn't be soaked out so easily. Okay. Now, so for that, what we are going to do, we are first sorting this one. So 1, 2, and 2 will be our new sorting value. Okay. So what we are going to do, initially height of tree is 0. We are pouring it with 1 liter of water. So 1 is greater than 0. Obviously, yes. So 1 will be added to it. Now our height will change to what? Height will be now 1. Now again you can see. Again the next water liter is 2. Now since 2 is greater than our current height of the tree, so it will also will be added to it. And the new height will be 3. And again there is a 2. So could, when we pour this 2 to this water, when we pour this water to the tree, so could it help to increase the height of tree? Let's check. So this case should be compatible to increase the height of the tree. So our amount of water is currently 2 and height of tree is 3. So this condition isn't valid. So this, even after pouring this water to the tree, giving this water to the tree, we haven't got any result in the increase in height of the tree. So our overall height of the tree will be remains as 3, and this is the maximum possible height that we can get. So this is our answer. Simple, it's simple. Now another output is there is only one water to pour, and this is of 5. Initially height of tree is 0. So 5 is greater than 0. So our height is 5. So by that means you get to see that this problem is very easy. Just we have to look for this condition. Whenever if the height is greater, but just sort the array, and if our current water value that we are pouring to the tree, if it is greater than the height of the tree, then we simply um, increase the height of the tree by the amount of water. Otherwise, we don't have to increase. It looks like a simple problem, but let me take one more example. You will understand the complexity of this problem very, very clearly by this example. So let's say if I have taken 4 buckets of water, and the bucket of water quantity as follows. First is of 1, second is of 2, third is of 3, and fourth is of 5. Understood it? Now, let's do it by the greedy approach. Okay. So first height of tree is 0. We are pouring with 1 liter. So obviously 1 is greater than 0. So height of tree is now 1, and this will be poured out. Go for the 2 one. Second. Okay, 2 is greater than the height of tree. So it will also will be added. So 1 plus 2 will be 3. Fine and good. Now go for 3. 3 is greater than 3. Is 3 is greater than 3? No, because 3 is not greater than 3. That is correct only. It should be strictly greater than 3. So this haven't get any significant increase in the size of tree, even after pouring this water to the tree. Now go for the 5 one. So yes, 5 is definitely greater than the height of tree. So it will affect the height of tree. Our new height of tree will be 8. So by this greedy approach, by checking every index by this rule, we are getting our maximum height of tree as 8. But can we find any other combination by which we get a height of tree greater than to that? Let's check. Let's just check. So if I will say you put this 1 glass of water, okay, so height of tree will be 1 again from 0 to 1. Again, if you skip that one, if you skip pouring this one, because it is on our hand to skip someone or not. Let's say we do not pour this water to a tree. Let's go. Okay, because we are in the combination. Here it is written. We are water in any order. So we arrange the water in that order that we haven't have to use this to height to us. Okay, there is no need to use this to height. So if we skip that one, and if we take this one, so 3 will be taken. Obviously 3 will be taken because 3 is greater than 1. So it will be new height will be 3. So now 4 is the new height of tree. Again, if we take 5, then what we do? What we do? So 4 plus 5 will be nothing but 9. So by greedy approach, we getting a height as 8, but if we are doing in some other way by some optimal secondary approach, then we get our height as 9. So I hope you understand that this problem isn't so looks so easy at it is looking to you, okay? Because the catch is here, we can do it in any order. So all the possible combination to be considered here to pour the height, not only one that we are using in greedy approach. In greedy approach, what we are doing, we are just looking for the next possible uh, good value and we are going according to that path. But since we have to look for all possible combination, and whenever I say all possible combination, that means that the recursion case occurs. And that recursion will be further implemented upon the dynamic programming. That's a secondary case. But whenever I say you that all possible combination we have to consider, and that means the recursion case occurs. And if you haven't cleared about the recursion, what is recursion, how actually recursion works, then I request you to please go and check out our course in online study for you channel, where I have made everything clear about data structures and algorithm in C++ language. I have taught you in C++. There also I have explained the multiple logics of how actually recursion work, why recursion is so important for you. So you go to the website and check out that, okay? But for that case, look here. So this case question haven't been solved by greedy. So we have to choose the recursion way because we are have to choose. So what we are going to do, we definitely have to sort the array out because that will be easy for us. Now, what we are going to do, since here what we are getting, we have two options for every, either we take it or not take it, either we take that or not take that in our answer array. So what we are going to do, same recursion tree, we are going to draw the recursion tree to understand this problem. So our array is 1, 2, 3, and 5. So this is our array. Now we are starting from this index. Our initially, let's say some variable which contains the maximum possible values. It is initialized to 0 only. It is initialized to 0 only. I hope you understood this one. Now, so go further, go down, go down. So what I am going to do here, so I have two options. Either I take that one or not take that one. Let's say take, I will write a short form as T and not take as not NT. Okay, that's clear. So if I take this one, if I take this one, then my sum value will be what? Sum value will be 1. And if I do not take this one, then my sum value will be 0. Okay, this is fine. If I take, my sum value will change to 1. And if I do not take this index in our consideration, then our sum value will be 0. Again, go for the next value. Go for the next value, 2. So again, for the 2 also we have two consideration. So here, from here we have two choice, take or not take. And from here also we have two choice, take or not take. Because in that way the recursion tree is being drawn. So we have two options, take or not take. Okay, let me draw not take. So if I take that value, if I take 2, so my new value along this path, because we have to look for every possible path. So along this part where we are taking initially 1, and now again we are taking this 2, so our new value will be 3 because this 2 will be added. Okay, we are taking 1 and taking 2, so new value will be 3. 1 is been taken, 2 is been taken. And if we take 1 and do not take 2, that means 2 isn't been taken. So we have to check. Our current value will remain as of 1. And here also we are checking one more condition, that before taking, there is a condition that the sum, which is currently the height of tree, okay, or you can say sum is height of tree, HT. Our height of tree, which is currently 1, should be greater than the value, should be smaller than the value, strictly smaller than the value that we are considering for taking or not taking. So initially our height of tree is 0. So there is two possible combination for 1 because 1 is greater than 2. So we can take it or not take it. Initially for this one also, 2 is greater than 1. So we can take or we cannot take. Both option is available for us. Now here on also 0, since 0 is smaller than 2. So here also both the cases occurs, either we take that or not take that. So if we take that, then our value will be 2 because we haven't taken previous value that is 1, but we are not taking this 2. So our new value will be 2. But for this case, if we do not take this one also, so our new value will be 0, remains as it is. Again, you can see from here. So now in this path, our height of tree is now become 3. So now when we are going to check for this question also, so can we take this 3 for this round to? No, we do not take, because height of tree is should be smaller than the 3, and height of tree is 3, which is not strictly smaller than 3. So we haven't any option to take it further. So this path is not possible. So for that, what we are only one path possible. We do not have to take it, because this path is always open. Okay. So we do not take that 3. So our new path will be 3 only. Okay. Now come for these possibilities. So this possibility is nothing but our current height of tree is 1, and we are checking with the value 3. So obviously 3 is greater than 1. So there again the two path occurs, take or not take. So now if we take it, then 3 will be considered. So new value will be 4. And if we do not take it, then value is remained as 1. Again, for this 2 also. For this 2 also, since 2 is smaller than 3, so we have two available option, either to take that or not take that. If we take that, then 2 plus 3 will be 5. And if we do not take that, then what you can say, 2 plus 3 will be nothing but, sorry, it will be remains as 2, because we haven't taken that value. And again, for the same, 0 is obviously less than 3. So we again have two options, take or not take. If we have not taken that, then value will be 3. And if we not taken then value is remained as 0. And now we move to the last part, that is 5. So for 5, this portion haven't any option, because we can't move further with this portion, because this has ended, but this path has ended. Now for this path, since 3 is smaller than 5, so we have two options, either to take or not take. So if we are taking, then the value is 8. And if we are not taking, the value is what? Not taking, then value is, you can say 3 only, remained as 3, same. Now for this one also, 4 is again less than 5, so we again take or not take. So if we take, the value will be again 9, and if we do not take, then the value will be what? Value will be nothing but remained as 4 itself. Again for 1 also, take or not take, 1 it will be 6, and not taken it will remain as 1. Now, if for 5, we do not take, because 5 is equal to 5. So there is only one option, not take, and it is 5 only. For 2 also, we take or not take. We take or not take. So can we take it or can we not take it? So if we take it, then 5 plus 2 will be 7. If we do not take it, then 5 plus 5, 2 will be remained as 2. For 3 also, take or not take, because 3 is again less than 5. So it will be 8, and it will be again what? You can say 5 is, sorry, 3 itself, my bad. Again for 0, we have to take or not take. If we taken, then value will be 5. If we haven't taken, the value will be 0. So this is the whole recursion tree that we have drawn. And here you can see all the possible combination that is possible is been drawn here. And amongst all the possible combination, the maximum value which is 9. And it is our correct answer, as I have explained you. And if you look closely, then if taken, not taken, this is the greedy approach. But which path give us the maximum value? This path, again move to, let me, sorry, this path, moving to this path, moving to this path, moving to this path. This path will give me the maximum value. Okay. So there are multiple paths that can happen in this question, and we have to select the maximum amongst all the paths. So it is nothing but the recursion value, and here we have to look for only to take that value or not take that value. Okay, so we are doing just it by recursion. But let's see, can we do optimize that problem, because recursion have a complexity of exponential complexity, so it will take very much time complexity. So can we reduce it to further? Yes, for reducing any recursion problem, we are using the dynamic programming, because since there are multiple paths and there is a chance for any path to collide any further, so we are using our dynamic programming approach. And in that dynamic programming is nothing but uh, a database where we store the previous value. So whenever this value occurs again, so we can fetch that value from that only. We do not have to process the same data again. And if you want to learn about dynamic programming in very much detail, then you can go to online study for you and check out the dynamic programming video where I have already explained dynamic programming in very much detail. But let's understand this problem in here by take not take, and then we optimize it to dynamic programming here only. So we are taking value or not taking value, that depends upon the two constraints that you have to look. The constraint is the height of tree should be less than the current value that we are going to take. If it is this case happen, that means we can either take or not take. Okay. So we are calling for both the position. We are taking it or not taking it. We are choosing both the way from here only. And whatever way gives us the maximum value, we are taking it only. And if this is not the case, if else case will occur, then we have only one choice to not take that. And we are going move further with that path only. You can see here, in this case, when this condition occurs, when the else condition occurs, when height of tree, which is 3, is equal to this 3, then we have only one path left to move forward. This path is closed for us. So this is what I am looking to tell you here. Okay. So this is the way to solve this problem. Now let me write the some pseudo code for you here. So what I'm going to do, let's say, okay, one thing I can do. So since this video is getting so long, so let me explain the pseudocode to you here. Then I am just showing you the code only and I explain you the code there. So that saves a lot of time. So now let's go further. So this is the case that I have explained you. So here I have two options to either take that and not take that, and that depends on this value. What I am going to do, I have calling a recursion function from my main function, and there, let me show you the code first. Okay, there I am explaining you the best. So this is the recursive code. So let me, okay. So I hope you are seeing this. So this is the recursive code, and here you can see this is the main function. Okay. So here I have taken n as input. Okay, and also you can see. Let me select any other pane. Okay, yes, this will be fine. So here I'm taking, okay, so this is fine. So n as input is being taken here, and here the array of size n is being taken as input. And then what I'm doing, sorting that. Okay, why I'm sorting, I have explained you, because this is the best thing that we can do. Now, after sorting, I am calling a recursive function. So recursive function is being called here. So from there, the recursive function is being shown. Let me show you the recursive function from here, where I have written my logic. And why I'm calling recursion, I have already explained you what is the benefit of recursion. Since in recursion, we are checking all the possible paths. Okay. So in recursion, I have passed the index initially as 0, because when I'm saying you that, let's say this will be my after sorting 1, 2, 3, and 5. So for this index, first I have to check, and sum will be initially assigned to 0. And sum is nothing but height of tree. Sum is a height of tree. Now, this is the base case. For any recursive function, we have to write the base case first, that in what case we are stop checking for all the condition. And this is the case when my index will be equal to n. So for this case, this is index 0, this is 1, this is 2, this is 3, and this is 4. So when I reach the index 4, that means I come out of all the size of array, then I will stop checking and I will simply, this will be the thing that I will explain you later, and I return from here. Why I'm nothing returning here? Because this function is returning nothing, because it is a void function. Okay. Now, so this is the case. So here it is the case where height of tree is less than the value that I am taking. So array of index is the value I am taking. So if this is the case, then there are two possibility to take that. This is the possibility to take. You can see I'm moving to the next index by adding that value in my sum. Sum is the height of tree. So I'm moving to the next value by adding that value in my sum. And and I am I have two options to take or not take. So I am moving or not moving to the next index by not taking that value. Here you can say I have taken that value. Array of index, it will be added to my sum, and here array of index will be added. Okay, let me show you the recursive tree. Okay, so okay, let me delete it. So this, you can see this tree. In this tree I have take something or not take something. So you can see here also the same thing. I have taken something or not taken something. Both the case will be valid here, take or not take. Okay, and now if this case is not happening, there I have only one option to not take. So this is the simple logic that I have explained you. So I am not taking that value in my sum, and I pass go to the next index. That means I have gone to the next value. So this is the logic that I have written. And now you can see from here that when my value is reached to the last index, that means I have got some value, then there is a val variable that I have assigned to here. Let me erase this. This is not working clearly. So this is the value that I have assigned here. And in that value, I have assigned the sum value that I have currently had by reaching to the bottom of that value. And I have assigned that value to my val. Okay, maximum value to my val variable. And amongst all the possible value, you can see amongst all the possible values. So every time there is a sum occurs when I end my one path, and among all the path, whatever will be the maximum. This is the maximum in this case. This will be stored in my val. And after that, after doing all the possible paths, I will stop my operation here. And what I will do, I will simply come down and return, okay, return the value here. Okay. Now the question arises, can you do the memoization of this code? So this code is a simple recursive code. Okay. And you can see this is since recursive code has exponential time complexity, because we are checking for every possible combination. So the time complexity will be 2 to the power n. Okay. So this is a time taking process to you have. So for optimizing this, we are using the concept of dynamic programming. Okay. So let me show the dynamic programming code to you as well. This is the same code of this as it is, but just a slight change to have. Okay. So just let me show you the dynamic programming code to you also. But before showing you the dynamic programming code, let me run this code for you so that you understood that this is the right code. Okay, you can see I have used the same input as in example test case, and I am getting the correct output as I have expected. Now, let's move to the, so now come down. This is the memoized code, or you can say DP code, which we are, in which we are using the memoization approach. And what is actually this memoization approach? This is the same code. You can see I am commenting down here for you guys, because if you see this video in some time, by seeing this video you get to understand what actually this code is meaning to you. Okay, so this is okay, why this zoom is doing so much. Okay, now, so let me expand my screen. Okay, so you can see better now. I hope you see this. So you can see the same code is being written, the same thing here also. Size of n is being taken here. One more thing has been taken, this total. Why I'm taking this, I will explain you in later. And I'm adding the total value. Total will store sum of values in array. Now, why I'm taking this? Because I have made one more DP array, 2D array, a 2D DP array, which will store uh, its n cross total uh, dimension. Okay, total is the sum of total. So why I'm doing this? Because I want to store every possible value that I'm seeing, so that when this value occurs again, so I will face that value from here only. Okay. So what is the maximum value we can get for n possible combination? We are getting a maximum value of total value, because when all are being added, when all are being taken, that will be the best case to have. So that is the maximum value that till which we can get, and n will be the maximum size which we can get. So n cross total plus 1 will be our 2D matrix size. Okay. And now what we are doing, let me show you. I am again calling the recursive function from here only. And you can see here I am defining the 2D DP array. And here also in the solve function, I am passing the same thing, just this is the same base case that is being called in recursion. This is the same base case that I've explained you in recursion portion. Now, this is the main portion that you need to consider here. So this is the benefit of memoization. Let's say, what is the benefit of this? So if I have gone for any index, let's say for index 3, I have got a sum of 7. So I will store 3.7 box, click that value with the value which I got. Okay, for 3.7, I write that I got 7. So again, if I visit that path, then I do not have to do the same process what I have done after this again, because when I again these 3 cross 7, then I got the value which is stored there previously as a maximum value. So I don't have to perform the same process again. I just go there and fetch that value from there. So this is the benefit of DP. And I already told you that DP is a very important topic for you to have. So please learn this topic from our website, Online Study for You. There I have explained it in very much detail. But if you are not what I can say comfortable with DP yet, so you can just write the recursion code also in your examination. That will also help you out, passing you some of the test case. There might happen that your out of 10 test cases, your 1 or 2 or 3 test cases will not be passed, but some of your test cases definitely will be passed by that code also. But I recommend you to learn DP in detail, because this is a very important topic for you have. But if you already learned, then you will easily understand this question. Okay. Now, so this is the DP part for you to have. Again, the same thing is being done here. Either we can take it. So this is the take portion. Okay. This is for the take part, and this is for the not take part, and I'm taking maximum of them. And again, if that is not the case, that means height of tree is greater than or equal to the water that we are pouring to the tree, then we simply doing what? Simply not taking it. And what we are doing here, just before returning the result to us, we are just updating that value to our memoization table, so that if we again get that value, we are reached to that value. So from here only, we return back. We do not have to do the same process again, and that saves a lot of our time. So this is the simple DP code for you to have. Okay. So let me run this code for you. Okay, okay, okay. Let me erase this. So you can see it is coming correctly. So now let me show you the Java code as well for the same problem itself. So this is the same Java code here. You can see I'm using the same memoization array for the DP problem. I'm assigning that value. The total sum is being filled up here. The same code to take or not take in the other case otherwise. And here also the DP code is being written for returning the value if we already have. And here I'm updating my DP table so that I can fetch that value in any other condition when I again occur on that value. And after doing that, I'm simply returning my result from here only. Okay. So this is the second code. So I hope you understood this code. And now let me take the same value as input. So 4, let's say 3, 1, 2, and 5. So let me run this. So this is the correct code output is coming. So I hope you understood both the code that I want to explain you here. And I wish all of you to best of luck for this examination. Please read all these topics because this kind of problem is being asked in regular examination. Please be prepared for the examination. You can check out our course as well. So thank you. Please, we will meet in some other videos with some other topics again.